Alright, so we're just going to do some chapter 1 word problems here. We just have 3 different kinds that I want to just cover today. So as a reminder, when we're doing these, the 2 main forms of our quadratic equations that are important here are vertex form and intercept form. So vertex form is where we have that a times x minus h squared plus k. Our axis of symmetry is just x equals h, and our vertex is h comma k. Intercept form is where we are factored. So you're often given equations in standard form and you have to factor to put it into intercept form. Our axis of symmetry is the average between our 2 roots, actually, right? Because we've now found out that if you solve for a quadratic, your solutions are going to be at P and at Q. So if you take the average between those 2, that's actually our axis of symmetry because that's right in the middle. And then the vertex here is your axis of symmetry for x, and then you plug in that axis of symmetry for your y. So the first kind of problem we're going to do here is we're going to look at distance problems. So this says that the Golden Gate Bridge in San Francisco has 2 towers that rise 500 feet above the road and are connected by suspension cables as shown. Each cable forms a parabola with the equation y equals 1 over 8,960 times x minus 2,100 squared plus 8. So right away, you should notice that this is in vertex form. So we want to know what the distance d is between the 2 towers, and we want to know what the height L above the road of a cable at its lowest point. So I'm interested in this distance here and in this height there. So notice both of those sort of revolve around this point right here, which is our vertex. And then we could also think of them as these points here. What is this distance? Which we could translate down, kind of if you consider this like your x-axis. So, with that in mind, for the distance between the 2 towers, let's first note that the vertex of the parabola is 2,100, comma 8. That comes right from that intercept form, or the vertex form. So a cable's lowest point is 2,100 feet from the left of the tower. So if you look here, from the left of this tower to this lowest point here, the horizontal distance is 2,100 feet. So maybe you can guess then, if we want that total feet, we can say since the heights of the 2 towers are the same, the symmetry implies that the vertex is also 2,100 feet from the right tower. And this is actually what our axis of symmetry tells us as well. Our axis of symmetry tells us that this distance is split in half. So the vertex will give us one of those halves, and then we can just add them up to get our total. So 2,100 plus 2,100 would be 4,200 feet. So we can say for part A, the distance is 4,200 feet. So that was kind of my part A. So you'll have a mouse jumping question, and it asks you the total distance, and this is essentially the same process. You'll have a vertex, your x of that vertex you're going to double, and that's the distance. We also want to know the height above the road at the lowest point, and this comes directly from our vertex, right? So our vertex was at was at 2108. So the other part of that vertex, if this 2100, if our x, you can kind of think of this as that horizontal distance. So for our axis of symmetry, and then our y, this is our horizontal distance, which means that our y is going to be our vertical distance. So from our vertex, we can just say the height L above the road at the lowest point, because that's what our vertex is, it's a lowest or a highest point, is the y of our vertex. So that means then that your height is 8 feet. So that's distance. You are really focused on the vertex form when you're talking about any distances usually, and just interpreting what the x part of that vertex is and what the y part is. Example 2, we're going to talk about area. I want to remind you the area of a rectangle is equal to length times width. And that's going to help us out here in how we're going to set up these equations. So you're, in the midst of your quarantine lockdown, and you're done making sourdough bread, and you've decided to turn to quilting. So you have made a rectangular quilt that is 5 feet by 4 feet. You want to use the remaining 10 square feet of fabric to add a decorative border of uniform width to the quilt. So we have a bunch of numbers and letters down here, but notice here that this distance right there is 4, and that this distance right here is 5. And then we have some other distances. So this distance we don't know, these uniform distances, these are x. So where this 5 plus 2x comes from is because this is 5 plus an x plus another x. Likewise, this distance is 4 plus an x plus another x. So that's where that 4 plus 2x and 5 plus 2x comes from. So when you're doing these problems, the general form is that you're going to do area of your border is equal to the area of quilt and border minus the area of your quilt. Right? So that's just saying if you have this total, so if I were to color this in here, if you have this total area here with the border and the quilt, and you know what the area of the inside is, you could just subtract the area of inside from that total to get just that blue outside area. So then we just have to fill in some things we know. We know that we only have 10 square feet for our border. So 10 is going to be the area of our border. And then the area of the quilt. This comes from this formula for area. The quilt plus the border is the ones with the 5 plus 2x and the 4 plus 2x. So 5 plus 2x times 4 plus 2x minus the area of our quilt is 5 feet by 4 feet. So now we need to do some simplification. So I have 10 equals, I'm going to FOIL this out. So I'd have 20 plus 10x plus 8x plus 4x squared minus 20. And now I'm going to simplify and rearrange here. So first of all, I'm going to rearrange this so that it goes my x squared term, my x term, my number. So we have 10 equals 4x squared. 10 plus 8x would be 18x. 20 minus 20 is just 0. I also want to pull this minus 10 over. So I have 0 equals 4x squared plus 18x minus 10. Now let's pause here for a moment. What are we actually trying to do? We have this now in standard form, and it's equal to 0, which should clue you in on what I want. But remember, x, our x distance here, is just the border width, right? And that's exactly what we're going to solve for. So if we solve for x here, that's going to give us the width of our border. And we know how to solve for x when we have an x squared. We need to factor. So we're going to use some of our strategies from before. first I'm going to look for a common monomial. These are all divisible by 2. So I have 0 equals 2 times 2x squared plus 9x minus 5. Now I have to do some factor by grouping. So I have 0 equals 2. This would be, oops, let me move this down. 2 times negative 5 is negative 10. To add to a positive 9, I'm going to do negative 1 and positive 10. So I have 2x squared minus 1x plus 10x minus 5. I have my two groups. From my first group, I can pull out an x, and I'm left with 2x minus 1. From my second group, I can pull out a 5, and I'm left with 2x minus 1. Then I have 0, my repeated parenthesis, 2x minus 1, and x plus 5. From here, I'm going to set my stuff equal to 0. I can kind of ignore that 2 out front now. So I have 2x minus 1 equals 0, and I have x plus 5 equals 0. When I solve here, this would be x equals 1/2. This would be x equals negative 5. So now you have to ask yourself, okay, there's two solutions here. Which one makes sense? If you're talking about a specific width, it doesn't make sense to have a negative width. So this one's going to be our final answer. So we can say the border should be 1/2 foot. So you have a problem that looks like this. That's the area of a school with its parking lot, and they want to expand the parking lot, and it's going to follow this kind of problem. Our last one is sort of the weirdest one. It's this maximizing revenue. So it says you maintain a music-oriented website that allows subscribing customers to download audio and video clips of their favorite bands. When the subscription price is $16 per year, you get 30,000 subscribers. For each $1 increase in price, you expect to lose 1,000 subscribers. So we want to know two things. We want to know how much you should charge to maximize your annual revenue, and what is your maximum revenue. So remember, when we have a parabola, the maximum of that parabola is again our vertex. So we're really interested in our vertex here. So kind of just like that first one. So first though, unfortunately, I need to build what my formula or my equation is, because I don't have that here. So it follows the general revenue equals your number of subscribers times the subscription price. And here's where it gets a little tricky. Let's name our x and our y value. So let r be revenue. And we're going to let x be the number of $1 price increases. That's a little confusing. So it's not the price increase itself, it's the number of them. And since it is $1 price increase, it sort of seems like that. But it's a little trickier to interpret. So my revenue here, we're just going to call r, or you could say r of x. And that's equal to my number of subscribers. So for my number of subscribers, you're going to take your total 30,000 subscribers minus 1,000 subscribers per price increase. Okay, so you're going to have another problem that follows this exact form, so make sure you know where each of these are coming from. So 30,000 is your beginning number of subscribers minus 1,000 per price increase, and that comes from this last sentence right here, times your subscription price, which in this case is 16 plus however many $1 increases you have. So from here, this is already sort of in factored form, but let's go ahead and clean this up a little bit. We're going to simplify this first part. I'm going to pull out a negative 1,000. So then we have negative 1,000. I'm going to switch my signs around too, so I want my x to be first. So it'd be x minus 30 times x plus 16, just because traditionally we have those x's first. Okay, so now notice this is an intercept form. Anytime you're asked to maximize something, you're looking for the vertex. And in intercept form, the vertex is that axis of symmetry and your axis of symmetry plugged in. And the axis of symmetry, remember, was that P plus Q over 2. So you have to identify your axis of symmetry here. So again, vertex is going to be axis of symmetry and your axis of symmetry plugged in, whatever your y is there. And what those will give you, the axis of symmetry is going to give you the value of x that maximizes your revenue. And the axis of symmetry, when you plug in that y value, is going to give you what your maximum revenue is. So my axis of symmetry, when you're in intercept form, is equal to P plus Q over 2. And remember, you have to switch the sign of your P and Q. So in this case, my axis of symmetry is going to be x equals 30 plus negative 16 over 2. And that'll give me x equals 7. So for part A, to maximize the revenue, I'm going to move this over here, sorry. Ooh, I grabbed my R. So to maximize my revenue here, it's not just 7, because remember it's 7 plus the initial $16. So we're going to say to maximize revenue, charge 16 plus 7, which is $23 per year. Okay, that's your answer to A. And then your maximum revenue, if you plug 7 in to your original function, so we have R equals negative 1,000 times 7 minus 30 times 7 plus 16. You could type this exactly like that is in your calculator, just without even the y equals. And this is going to give you that your revenue is equal to 529,000. So that's your maximum revenue. So that would be your answer to part B. 529,000. So the last example looks like this problem, and you're just going to write an equation, and then you're going to find the vertex, and just interpret what that vertex means.